we'll be taking a look at gas laws. Now, in order for us to really understand gas laws, the first thing we need to do is that we need to understand the characteristics of gases. Basically, what are the characteristics of gases? Number one, characteristics of gases. Characteristics of gases. Yeah, number one, they have no fixed volume. They have no fixed volume. Now, because they have no fixed volume, what they do is that they expand to fill any empty space that they have. That's what they try to do. They expand to fill any empty space. Number two, they have no fixed shape. They have no fixed shape. In the same vein too, they can be compressed. They can be compressed easily by applying pressure. By applying pressure. So we compress them by applying pressure. Number four, they are transparent. They are transparent. What that means is that one can see through them. You can see through gases. That's what it means for it to be what? Transparent. You can see through it. Now the next one is that they diffuse rapidly in all directions. Number five characteristics. They diffuse rapidly. They diffuse rapidly in all directions. In all directions. And last but not the least, when heated, they expand. When heated, they expand. Each one of these explains the characteristic of what? Of gas. The first one is they have no fixed volume. The second one, they have no fixed shape. The third one, they can be compressed easily by applying pressure. The fourth, they are transparent, meaning you can see through them. Five, they diffuse rapidly in all directions. And six, when heated, they expand. So all of these give us the characteristics of gas. Now, the behavior of gas can be explained by the gas laws. The behavior of gas can be explained by the gas laws. Are you following me? It can be explained by the gas laws. And what are these laws? What are these gas laws? We have Boyle's law, Charles' law, ideal gas law, Dalton's law of partial pressure, ideal gas equation, Graham's law of diffusion, Lusak's law, and Avogadro's law. These are the laws we'll be looking at one after the other. So I would like to highlight all of those laws. Let me highlight all of those laws. I think we are done writing all of this. So like I said, gas laws, the gas laws that will be studied in this class include Boyle's law, Charles's law, ideal gas equation, Dalton's law of partial pressure, Dalton's law of partial pressure, Dalton's law of partial pressure, Graham's law of diffusion, Graham's law of diffusion, Lusak's law, and the Avogadro's law, That'll be 1, 2, 3, 4, 5, 6, 7. We'll be studying 7 laws in the course of this class. So take it from the beginning. The first law, which is described as Boyle's law. law called Boyle's law. What does it state? Boyle's law states that the volume of a given mass of gas is inversely proportional to the pressure, provided temperature is constant. So meaning that of the three properties that you can use to describe a gas, one of it is kept constant in this case, and that is what? And that is temperature. So mathematically, what we are saying is that P is inversely proportional to V. That's what it means. That P is inversely proportional to P. And because of that, if we decide to introduce the constants, now the P is equals to what? To K over V. So by the time we collapse it, this will be PV is equals to what? K. Now by comparing it to another, because it's a constant, it has to do with the constant. So meaning that as the pressure increases, the volume decreases. So what will happen is that you say P1 V1 is equals to what? P2 V2. So what it means that you are comparing the pressure and volume in a particular instance to what? The pressure and volume at another instance. So this is how you solve questions on it mathematically. P1 V1 is equals to what? P2 V2. And of course, you know that what? K is what? So P1 and V1 are the pressure, the initial pressure and volume of the gas. The initial pressure and volume of the gas, while P2 and V2 are the what? Final volume and pressure of the gas. So that's what it just means. Now, the graphical representation of Boyle's law. How do you represent it graphically? The graphical representation of Boyle's law. The graphical representation of Boyle's law. Graphically. Now, if we decide to actually just take P to be proportional to V, are you following me? If you decide to say P is proportional to V, what you'll be having is something like this. You'll be having a linear graph. So this is not the graph. This is not the graph of Boyle's law. Now, the graph of Boyle's law is telling you that what P is inversely proportional to V. So this is the appropriate thing to do. So from here like this, we have this. So it's telling that as this is increasing, 1 over V is also what? Increasing. But if you're looking at it in this instance, this is what you have. So yeah, of course, our P is pressure and V is what? Volume. So if you are trying to represent it pictorially, pictorial representation. For the pictorial representation, what you have is this. You have this. And this is pressure. Then this will be volume. What this is telling you that as pressure, is what? Decreasing. Volume is what? Increasing. So that's what it's telling you there. So we'll move on to the next law. Of course. So the next law is Charles's law. Now, in the case of Charles' law, another name for Charles' law is absolute temperature law. Absolute temperature law. Now, what we are saying in this law is that the volume of a given mass of gas, of a given mass of gas, is directly proportional. Directly proportional. So in this case, it's different from Boyle's law. In the case of Boyle's law is what that is inversely proportional. It's directly proportional to its temperature, or rather to its absolute temperature. Its absolute temperature, provided pressure is kept constant. So in this case now, pressure is constant, unlike Boyle's law where temperature was constant. Now in this case, we have that mathematically V is directly proportional to absolute temperature T. Are you following me? Now please, that will mean that V is equals to what? KT. Now if you try to compare two gases, that will be what? V1 all over what? Okay, so this will be V over T is equals to K, meaning that we're making a constant set of formulas. So by comparing, that will be V1 all over T1 is equals to what? V2 all over T2. Now what this means is that the volume of gas we say that V1 and T1 are the initial volume and temperature, while V2 and T2 are the final volume and temperature. Now what it means, now you should note something, that your temperature is absolute. So meaning that temperature is in Kelvin, always in Kelvin. So even if you are given a question that says that it is in degrees Celsius, you must always convert it to what? To Kelvin. Why? Because T or R rather, TK is equals to what? This is temperature plus what? 273. So if you are given temperature in Celsius, so all you just need to do is to what? Add 273 to change it to what? Kelvin. Temperature in Kelvin. When you are dealing with gases, your temperature must be absolute. So now what's the graphical representation? The graphical representation. Graphical representation. So graphically, how do you represent Charles' law? Now graphically, this is how Charles' law looks like. So at this point you have minus 273 degrees Celsius. At this point you have 0 degrees Celsius. And here you have what? This is in degrees Celsius. Yes. So now, note something. There's a practical sense here. At minus 273 degrees Celsius, this is what you call your absolute. That is your absolute zero temperature. So this is volume anyway. Your absolute zero temperature, that's what we call it. That is when you have minus 273 degrees Celsius. That is the absolute zero temperature. Now at that point, at this temperature, there is no pressure, and no volume again, as well as no velocity. Are you getting me? There's no pressure, there's no volume, and there's no velocity of gas. At that point, your gas, in practice, at that point, your gas would have even solidified. Is it that the gas would have solidified or liquefied at this point? Is it that it solidifies at this point or liquefies at this point? Why? Because at that point you don't have pressure, at that point you don't have volume, at that point you don't have velocity. So you have what? It's absolute zero temperature. So pictorially, if you're trying to represent it, let me give you a moment to. Pictorially, Charles' law is represented in this form. So that tells you that it is what? Increasing and increasing. So it's a direct relationship. Are you following me? It's a direct relationship. So the next thing we're looking at is the general gas equation. We're looking at the general gas equation. The general gas, so we have the ideal gas equation. Ideal gas equation. So basically the ideal gas equation or general gas equation is simply a combination of what? Boyle's law and Charles' law. It's just telling us that what? That the kinetic theory, all the assumptions of kinetic theory is true. Of which in practice you can never have an ideal gas. But it's telling you it's a combination of both Boyle's law and Charles' law. It's a combination of both. So now basically we know that Boyle's law is what? P1 V1 or P V is equals to what? Is equals to constant, and Charles law is telling us that what? V over T is equals to a constant. Now, upon combining both equations, what you'll be having when you combine both equations, what you'll be having is that what? Is that P V over T is equals to what? K. Are you following me? Where K is the gas constant. In some cases, you can see it as R. Instead of K, you see R. It still means the same thing as the gas constant. So by comparison, your P1, V1, all over what? T1 is equals to P2, V2, all over what? T2. So that is your equation. So basically, in practice, this is not possible in practice. It is assuming that everything about the kinetic theory is true. It's not. So the temperature must still be the absolute temperature also. The T1 is the absolute, or T is absolute temperature, meaning that it must be in Kelvin. Meaning it must be in Kelvin. So this is where we stop for today. So what we'll do is, in the next video, what we'll be doing is we'll be looking at other laws as well as the calculations. Thank you.